Alright, so we're told this particle moves in simple harmonic motion, the amplitude's A, the maximum speed is capital V. So let's just go with, so we know if it's simple harmonic motion, it looks like that. And we know the maximum speed occurs when x equals 0 at the centre of motion. That's where the maximum speed is. So we can see that v squared is going to be when we have n squared a squared. So big V squared is going to be equal to n squared a squared. All right, so let's see if we can use that. So let's go back to v squared equals n squared a squared minus, and it says find its velocity when x is a half a. So let's make x a half a. We're going to square that. So you can see that we're going to have, if we expand that out, n squared a squared minus, so this is squared, and then we've got a squared n squared again. All right, so we've got 1 minus a quarter of these n squared a squared, so that's 3/4. Oops, 3/4 of n squared a squared. So you can see that v squared is going to be, oops, that is v squared, so we can see that v is going to be plus minus if I square root both sides. N squared a squared is v squared from here, so this will just be capital V. So v is plus or minus square root 3/2 of that maximum speed. All right, so what about its displacement? So this time we want x to be the subject when v is half v. All right, so let's make it half of the v. We've got n squared a squared minus x squared, and we're looking for x squared. So here I've got a quarter big V squared. Big V squared is just n squared a squared. Oh, I'll just do it here. So that's also, actually I want to keep a's in there, don't I? So what I'm going to do, so I'm looking at what I'm trying to get here. So I'm going to change that, sorry. So that's v squared, which we know from over here again is n squared a squared. And here again I'm getting a n squared a squared. And I'm also going to get minus, I'm going to actually keep it like that, a squared. All right, so let's cancel those. So now we've got, if I make x squared the subject, I'm going to get 1 minus a quarter, so 3/4 a squareds over here. So x is again plus or minus the square root, root 3/2 a's. All right, so we also want to prove these general results. So you can see the next one has a capital V in it, so it's got the maximum speed in it, and it doesn't have any n's in it. So I'm going to change, let's go start again. So v squared is n squared a squared minus n squared x squared. If I expand out this first equation again, and we know n squared a squared is capital V squared, so I've got that in now. I also have to get rid of this n squared here. So just rearranging this one again, n squared is V squared on a squared, so I'm going to put that in here to get rid of that. And then if we think about it, that capital V squared, so let's factorize by that, and you get, whoops, should get that, which is this one we're looking for, almost. We just need to square root. So let's move a little bit up there. So that means our velocity, little velocity here, equals, so we're just going to take the positive when we square root. So big V square root 1 minus x squared on a squared. All right, that's that one. So let's look at the next one. So if we have a look at the next one, sorry, you can hardly see it here. So it's x, so it's displacement that we want, and we want a's and v's, but again, we don't want any n's. So let's rub this out. So we can see that. We don't really need that either. All right. So if we start again with our v squared n squared, a squared minus x squared. Think about what you want to get rid of. So we've got v squared is, so n squared a squared is our capital V squared. And then again, we want n squared x squared, and we want to get rid of that. So let's do that again. This time we want x to be the subject, don't we? So I'm going to put the whole of that x part over this side. And there is the rest. All right, so x squared, we need to times by a squared and divide by that. All right, so we're square rooting and we're just taking the positive. So, actually I'm going to put the v squared inside to get what they want, because they only want to put the a on the outside. So actually we're putting the big v squared under here instead of here. So I've got the square root of, okay, so that's going to be v squared on v squared is 1 minus little v squared on big V squared. All right, so that's what we wanted there.